Hey, what's going on, guys? Let's do this problem right here. So we have a bug right here. It walks on the water. So some bugs can walks on the water. So let's assume this one can walk on the water and solve this problem. So we have the bug that walks, and the question is, what is the length the bug's leg is making with the water? So that's the question. So we have the theta, that's the question, and bug has 6 legs, and each leg has circle feet, and they have given the radius, that is 0.2 millimeter, and mass of the bug is 3 times 10 to the power of minus 5 kilogram. And let's see how we can find the angle the bug's leg is making with the water. So let's see. So first of all, we have to know the coefficient of surface tension, that is for water, that is equal to 72.8 dynes per centimeter. And then we have the equation for surface tension. Force of surface tension is equal to gamma L cos theta. So we have to find the theta, but FST can be replaced. We have the mass right here, so we can write this equation as mg is equal to gamma L cos theta. And since the bug has 6 legs right here, so each of the leg has feet. Circle feet mean the length of the circle is going to be 2 pi r, so 6 times 2 pi r. So I'm going to write L 2 pi r instead of L. So this is going to be mg is equal to gamma times 2 pi 6 times 2 pi r. So gamma times 6 times 2 pi r cos theta. We have to find the theta, so let's rearrange this equation. This is going to be cos theta is equal to mg over gamma times 6 times 2 phi r. So we have to find the theta. Theta is equal to cos inverse mg over gamma times 6 times 2 phi r. So this is the equation. Now we have all the values. We have the mass right here. We know that g is 9.81 and gamma is also here, and then we have the radius also right here. So we can now substitute all the values and find the answer, but in this case we have too many different units right there, so we can write everything in grams, centimeter, second format. So let's write in that format. So we have 3 times 10 to the power of minus 5 kilogram, that is equal to 0.03 gram. And then we have 9 point, the acceleration of gravity is going to be, gravitational acceleration is going to be equal to 9.81 meter per second, and if I convert into centimeter, that's going to be 980 centimeter per second square over gamma, that is 72.8 dynes per centimeter. Then that is multiplied by 6 times 2, this whole cos inverse. I forgot to put cos inverse right here, so we have to put cos inverse, and all comes in the bracket. So 6 times 2, 5 times r. So r is given in millimeter, so 0.2 millimeter, that is equal to 0.02 centimeter. And if I calculate this value, if I plug this all in the calculator and find the value, this gives us cos inverse 0.5356. This actually tells us that bugs really can walk on the water, because if the cos is equal to 1, or if it's greater than 1, the bug can't walk on the water because the legs will go down to the water, because the 1 is the maximum angle that can have. So in this case it's lesser than 1, so that's mean the bug can walk on the water. And the angle that's going to make is, if you plug this one into calculator, that's going to give us 58 degree, and that's the final answer. I hope you guys liked this video. See you next time.